morning, everyone. Still early. 5 minutes before we would. Oh, hi. 5 minutes before we would start, so we still have time. Early. 5 minutes before we would. Oh, hi. Okay, so I thought someone said something, but I'm hearing myself playing on YouTube. 5 minutes before we would. Great start. All right, stop that. Okay. I'm going to switch on my camera on YouTube as well. That makes it a bit more personal. For the people that are already here, I hope you're doing fine this morning, today. If you have any questions that you maybe had after last week or during this week, maybe you had another look at the materials, feel free to ask them in the chat. Maybe we can already discuss them now or otherwise later on during the workshop. So not that it's really interesting, but just to fill up the time a little bit. For those who are curious, last week I showed the slides in plain HTML, which you can download from a notebook. But it's also possible, and this is now Jupyter Notebooks here, it's also possible to have a cell as, yeah, you can create slides from a notebook. So each cell will then be a slide here. You can select whether it's a slide or it's a sub-slide, which then means that it's part of the slide there above. And then there is this extension, Rise Slideshow it is called. And then you can have them like live, which is pretty cool, I think, because now I can start coding here as well. So I can have a presentation and be coding at the same time. In the meantime, we still have a little bit of time before we can get started. Good morning to everyone that's joining now. I guess that since no one is asking anything regarding the setup, that everything is working out fine. So you can hear me on YouTube. And here on Discord, everything is working as well, I guess. So you have 8 people following here and on YouTube. I closed YouTube. That's okay. Good morning to you too, Els. And Federico and Eva. I don't think we should wait for everyone to join us, but maybe 1 more minute. guess at some point even my colleague James will join us. Once again, he's late, I guess, but that's what software developers do best, I think. So I was just telling to the other ones that it is possible in Jupyter Notebook, well, in Jupyter Lab as well, but I didn't find really how exactly I can change it. In Jupyter Notebooks, it's more straightforward to create slides from the contents in a notebook, and then you'll have to here you can, I don't know if you see it on your notebooks, but I can select here whether this is nothing specifically or it's a slide or a sub-slide. And last week I just downloaded them, download as, I guess, HTML or slides.html, which will then render a file which you can open in your browser, which represent the slides. But there is an extension in Jupyter Notebooks, which is pretty cool, I think. It's called Rise Slideshow. And then, well, if the content looks fine, let's say, if it makes sense in the Rise logic, then you can just click it and it will show up as slides. There's one more file I need to open before we get started. Python. All right. So I hope you're all well this morning, fresh minds for the last day of the Python workshop. Today, well, maybe we can go over the materials again, which we will cover today. So the first thing that we will cover, which will be for this morning, is functions. And it's actually not a big it's not a big chapter because there's not much to be said about it. It's more about practicing, I think. So we'll definitely have the time to also tackle our project exercise, which basically tries to write everything in functions in the last part. So this is a very important chapter. We will talk about modules, which helps us to I call it not to reinvent the wheel, because there's a big community behind Python, and a lot of people have already created great packages and extensions which you can use for different purposes, like parsing Excel files, plotting static or interactive figures. You name it, Python has it. And so we will have a look at a couple of built-in ones and how we can call them and what's like best practices in it. And then also very shortly something about plotting, and we chose the very basic but very important library as well. It's called matplotlib pyplot. And we will cover some basic figures and then a bit more special ones to show you what you all can do with matplotlib. If you have a specific question as to, like, I joined this workshop because I have this data laying around and I want to do something with it, feel free to ask it in the chats. And I guess that today at some point we definitely would have time to discuss it as well. Maybe not in detail, but at least, I don't know if you have any specific question as to how can I get started with it. Maybe James or I can give some good tips, I don't know, to get you started. And there is a question in the chat. When I just launched Jupyter Lab, the kernel sessions shows previous notebooks with shutdown, meaning they are always running even when I was not working on it. Does it occupy a lot of memory? As long So yeah, it is true if you reopen your notebook or your Jupyter Lab session that it reopens the ones that were, yeah, which you probably didn't then close the last time. Does it use a lot of memory? I don't think so, because I would imagine it is something like you have your mails running in the background. So it is there, but it's not really occupying a lot of memory. Though it would be a different thing if you're running stuff. So if you're running computations the whole time, that will require, yeah, computational power, and hence might slow down your computer. But yeah, if it's just there on the background, I don't think you should be worried. My idea was that we start with the quiz again. This time a bit shorter though, because last time was maybe a bit too long. So I have a couple of questions to get us started, and then we can dive into the functions, if that's all right. And I have here next to me the questions which I will, yeah, the same questions which I will put in the chat in Discord. And so there will be the same poll again. So once the questions are there, you can, in the chat, check the options there. So the first question, which of these if statements are syntactically correct? And once again, multiple answers. Are possible. Yeah, it's working. And people are answering, so that's good. We're awake. So no one is voting, or almost no one is. Good morning, Sylvia. Almost no one is voting for C or F. Yes, no, a little bit, maybe. I guess that A, B, D, and E are indeed the most obvious. Let's have a look. You can't really show much here, but imagine that A and B are, for example, Boolean values, then this would be a correct expression. So this could be a valid possibility. In this case, we're checking, for example, the length of a string. If it has 23 characters, then it would be okay to continue. So that's also fine. But is something which we haven't seen, and that is obviously because it doesn't exist. How can you also see it? Because it stays in black. In Python, well, in Jupyter at least, I'm sorry, if the word has a meaning, like if or length or end, then it lights up in green. So C is not possible. D, yeah, given that A is a value to the power of 2 greater than or equal to 49, so that's also possible. In the E case, also, let's say that A is some integer, it can be either equal to, or in this case, not equal to 3. So that's also valid. And technically, also, the last option is possible. In this case, it's just a combination of these logical operators. So with the brackets, we're checking first whether A and B are true, for example, or whether C and D are true. So it is possible to have like multiple logical operators combination. If something is not clear about that, feel free to ask me. Which of these while commands are correct? Yeah, without, yeah, I don't need to really specify it, I guess. I am copy pasting the options in the chat in a second. And there we go. So which are correct? This is really nitpicking. Addertjes onder het gras, I would say in Dutch. If we can have a look at it, indeed B has been voted the most for together with D. So those, yeah. So what, yeah, not really true. It's really nitpicking actually. I'll go over them one by one. So in the first case, well, you're assigning a value 1 to the variable a, which is not possible actually. Not at least where it expects to be a condition. So this is not correct. Here we're checking the length of a variable that contains either values or it's a string. So this will evaluate to something which is possibly correct. Or at least it's technically possible. The third one is also possible. Looks a bit strange. I wouldn't write it myself like this, but I guess if a is some kind of boolean and maybe b minus 2 is equal to c, this could evaluate to something that is correct. The fourth one, I'm very sorry. It's because there is no colon here. But other than that, this would be possible. Because here, indeed, we're having two equal to signs, which is an equality check. So is b equal to 1? And so this is possible, and it's something else than the option A here, the first one. And then the last one is, find, let's say that S is a string, then we're going to search in that string, we're going to find a letter C, and if there is one, it will evaluate to the index of where it can find it. So imagine that there is a character C on the 4th place, then it will return a value, in Python counting 3, and so 3 is larger than or equal to 0, and then hence it will evaluate to something correct. If I guess it will be none if there is no C in this occasion. So that's why it still will render something which is possible. Yeah. So this time a bit more theoretical. Which of these statements are correct? So while is also called a conditional loop. Not sure if I already called it that. The expression after while may contain a function call. It is possible to write endless loops, endless while loops. The colon after the while may be omitted, and I need to copy paste the question also in the chat. And the code block after while is executed at least once. And the distribution of the answers looks quite nice. Answers still coming in. So if you look at the answers, indeed, while is also called a conditional loop. I don't think I've mentioned it before, but if you break it down, it's indeed, it contains a condition after the while keyword, and it's a loop. Yeah, at least, yeah, because it's, yeah, it's part of the for and while loops. Obviously, I don't know how to explain. It's a loop because it's a loop. The expression after while may contain function calls. Yes, very important. Maybe, especially if we go on with the next chapter, function calls can happen at any place, at any time. It is possible to write endless while loops. As we've seen last week, it is indeed possible. The colon can never be omitted, so we always need to write colons. Well, at least after the while or if or for loops, for example. And the code block after the while is executed at least once. Maybe you were confused with what I mean by that. Let's say that the code block represents this part. I hope that it is clear that it is not per se the case. Because if the condition after the while statement is false, we will not execute the code block underneath it. We will immediately move on with the next statement, which might be at this location. You can use continue to execute block after while. So indeed, there are keywords which are called break and continue, which we don't cover it here anymore, but they are indeed made for, in specific cases, you might be into a while loop or you might be in a for loop and you want to break out of it given a specific statement, given a specific condition. And that's where, or you might want to skip the next part of a code block in a while or for loop. Then it's possible to do that with continues and breaks. So yeah, you can write it down and search something about it if you're interested in this behavior. But we will not see it anymore here. So that's called break and continue. So the third last question, which of these four commands are correct? And I'm copy pasting again in the chat. And I'll give you one answer. The last one is correct, but it's only correct given a specific, condition is maybe confusing. What do you need sec variable to be if this would be correct? So what does the variable sequence, for example, here needs to be if this would evaluate to something which is technically correct? So you need to define sequence, indeed. That's the first. sequence needs to be a list. So that's one of the correct answers, or range is also one of the correct answers. A dictionary could also be a possible answer, and a tuple is also a possible answer, or a string is also a possible answer. Generally, we call that a variable which is which contains multiple values. Something which the for loop can iterate over. That's what we usually set. So one by one, then we can indeed iterate over a string. So in this case, the character variable, in every subsequent for loop iteration will pick up one of the letters here. So in the first iteration it will be A, in the second iteration it will be B, and then C, and then D. The second one is also possible. In this case, we're creating an iteration over a ranging function going from, well, a ranging list going from 0 up till 9, so 10 not included. Here we have a tuple, so num is going to pick up the value 4, 6, and 8 in each iteration. The fourth one is not possible because 3 plus 7 will evaluate to 10, and 10 is just one value. And we cannot iterate over one value. So that's why the fourth one will not work out. If you try it, you will get an error from Python, and it will say something like, it will point to this line and say that it's not iterable. And so the last one is indeed, well, it can be correct, but only if sequence is something like a list, a tuple, or a string. Before last, and now the obvious reasoning, which of these commands will not create an error? And now I need to copy paste again. And also here, they are a bit tricky. So if you didn't have, if you had a lot of mistakes, let's say, in the quiz, it's not a bad thing. Don't feel bad about it, because I'm really giving answers that are exceptions on rules often, or like very nitpicking details. And I'm explicitly doing this because then we know again the very details of specific commands or Python programs, scripts. What we have: 11 for A, 6 for B, 8 for C, 3 for D, E 4. Yeah, and some changes. Unless Python came up with a new thing. The first one is not possible. Because it has not, count doesn't exist on a dictionary. So we can use count on lists. I wanted to start with strings for sure. I guess lists as well. But it doesn't exist on dictionaries. So it's a bit nitpicking. I don't expect you to know all of the methods that you can do on dictionaries, for example, but at least the count is not possible. How can we check? How can we know? Using the direction, the dir function. If I'm going to run this now to ruin the layout, yeah, cannot really do anything with it. But here at the bottom of the list, we will see all of the things that we can do on a dictionary. And that's not now possible. Pop is a valid method on a dictionary. Keys is one. We can use the get method to check whether there is a key with the letter F. So A, C, D, and E. There is no F, but it will return a non-value then, because F doesn't exist, which is a different thing if you would try to slice it out. The last one is not possible. If we were to try to slice out the value A, that would evaluate to something which is possible. Well, to alanine, because it's... Yeah, I can't run it because of the count here. So this will give alanine. If we try to do that with F, which doesn't exist, we will get an error. But also, you might think that we can do something like this. Using the squared brackets, we're trying to slice out a key with its appropriate value. So the output will be the value of the key that we're slicing out. In this case, we're giving it a value which will give an error because, yeah, Python expects you to give a key. And since it doesn't has the key alanine, so ala, it's going to give an error. And this is giving me an error here because of the first problem here. If we rule that out. Yeah, we're not getting anything back, of course. Anyway, the last example, the last question, which of the following blocks will print a file line by line? And I'm first copy pasting, I think. No, I'm not going to say something. So given that example.txt is a valid text file with multiple lines, of course. I'm happy that the example that we showed most often in the workshop is the one that you all agree on, that it is possible, which is B, indeed. So to fresh up our minds again, we're creating a file handle. So this is a link to open a file, which is called, in this case, example.txt, perhaps. And then we're using this file handle. Oh, I'm very sorry. We're using that file handle together with the method readLines to read all of the lines into one variable called lines. And then we can use this lines variable, which contains then a list of all of the lines to iterate over. And then we say, for example, for each line in that variable lines, we're going to print out that specific line. So this is definitely possible. The first one is also possible though. I've showed it very briefly. If you want to test it out, it's in files, somewhere at the bottom, I think. Didn't we? Or it's in some exercise. So there is a possibility to use this expression in which we are just iterating immediately over each line in that file handle. So Python will be able to immediately parse through that file by just using a for loop on that file handle. So this is possible. Didn't really stress it, so that's probably why you also didn't know it. My apologies. The last one, however, it is technically possible, but it's going to give a very odd result. Why is that the case? Because it will read in, well, this expression evaluates to one string that contains the first line. So say that the first line is hello world, then this iteration, this for loop, will iterate over each character in that one string. So the first iteration, it will be an H, then an E, then an L, then an L, then an O, etc. So this will actually just print each character separately instead of the lines, all of the lines. And that's... so that's what's happening here. So this will evaluate to the first line, which contains, this is the first line in the file readfile.txt. And then we're printing out each line, we think at least, but actually we're just printing out each character separately. For those who were not there this morning in the chat, or not so early, one of the questions was, do you always need to have the file in the same directory as where you're running the notebook or your Python script from? The answer is no, because Python came up with, it would be silly if we always need to make sure that we have the Python scripts in the same folder as the data files, for example. So logically, it is possible to create some path towards a file. So in this case, if you would have a look at it, I'm running this notebook from the solutions folder, which is here. And the data file, readfile.txt, is actually in here in data. So what I needed to do is go one level back, go into the data folder, and then find the file over there. So that's what's happening here. The two dots represent go one folder back. Then you can go to the folder data, and there you should find readfile.txt. And there is a library which is called OS, which we will cover in the module section, which helps us with creating these paths to files. They actually just help us to work with our local computer and all of the folder structure that is there. Okay. Given all of this refreshment, are there any questions at this point, or do we feel comfortable tackling the functions chapter at this point? I'm waiting for a second because the people that are following on YouTube have some delay. Can you use the folder name as in Windows, like copy paste the path? So there is a difference between how Windows creates paths to files, which is double backslash, whereas Linux systems and hence also Python by preference uses forward slashes. So you need to be attentive as to how you give the path towards that file, but the names of the folders, you can use them exactly. They can be exactly the same. How should I better explain? The name of the folders are definitely just copy pastes. Let's have a look at one of these folders here. Otherwise, so I'm opening a folder. Sorry, and I will show you in a second. I will show you in a second. I just need to find where. It's in documents, of course. I'm sorry for being slow. Okay, so this is my Windows folder. If I would copy paste a path, for example, the path to the data folder from here, if I would use this, I'm just going to open a new cell here then. So this is not going to work because we're using backslashes here, and Python is normally expecting forward slashes, like path to data file, something like that. If, however, you use the OS library, it will figure it out by himself if you're on a Windows system or on a Linux system, and then it will create, we will see that later. If we're creating a path to a file with the OS library, then it will create 2 backslashes himself, which is happening behind the hood here for this anyway. I'm explaining it too complicated, I think. We'll get back to it maybe. Sorry. Okay, so I guess if there are no other questions than that, I think it's all right to get started with functions. So basically what we've been doing up till now is we've been writing sequential code, you could say. We've been writing blocks of codes in all in these cells in the notebook. And basically this is fine as long as we're not doing too complex stuff. But as soon as our scripts become more complicated, it becomes more lengthy, then sometimes it makes more sense to store this block of codes in functions. Especially, for example, you have one long script, and in this long script you need to calculate the average of a list with integers on different occasions. Let's say you have to do it 5 times. What you might do is writing that block of codes 5 times separately in your code. That is not really good practice, because imagine that you then find a mistake in that code. Then you need to think about the 5 times where you've written it, and you need to correct it 5 times. Whereas if you would have transferred it into a function, for example, the function calculate average, then you only need to change it on one occasion. And because of you can call that function within your script 5 different times, if now something is wrong or you want to add something to that function, you only need to do it in this one occasion where you define that function. So that's what we will cover now. If James were here, he would say functionize everything, which is actually true. You're not really convinced to do that, I would say, in notebooks, because of this. Yeah, it has something sequential itself. You're going from the top to the bottom of your notebook, and you can just enter your scripts there, like underneath each other. Though, try to like put it in a central place in your brain, that it's very important to try to make functions of every step or of every code block. Especially when you're going to do some more complex things. So that for the introduction. Let's have a look at how we can create functions ourselves, and to very briefly mention that we've already been using Python built-in functions. There are a couple of them, but not that many actually. For example, we can get the length of a variable, a string or a tuple or a list, whatever, but we cannot, for example, calculate the average of a list of values. So some of the obvious functions that you might think about are maybe not possible in, or probably not possible in Python, at least not with the built-in Python functions. So yeah, that as a side note, creating our own functions often makes sense, and we will always do it in the same way. And the more complete way of showing you how a function is defined is as such. And basically, what can you see? It always starts with the def keyword, which represents the definition of. We're telling Python we're defining a function here. And the function has a name. In this case, we've called it name of my function. Okay, so this you can choose obviously yourself. It is followed by, within brackets, a list, well, a number of arguments that you need to give that function. Okay, so in this case, sum, function, and arguments are 3 different arguments that you need to give that function in order to do its work. Also here, just like the if, for, while statements, we end that line with a colon. And then underneath it, we have in indentation a code block, which is all of the code that needs to happen in that function. Okay, so in this case, you can see that we're calculating, we're adding sum to the multiplication of function and arguments. And the result that we get from this calculation, we're storing in the variable result. So we can create the variable results in, well, we can create new variables in a function, which makes sense somehow. And then we're ending the function always. Well, always, you do not have to, but more likely you want the function to do something. It calculates a result, for example, and you want to use that result later on. If this is the case, then you need to return whatever it has been calculated within that function. You have to return that to the user. Okay, you have to return that out of the function. And in this case, we're returning the results. So here we're writing down the variable results to say we want to use that result later on again, and hence whatever you calculate in the function, give it back to us. Okay. The line that I'm highlighting right now is called the docstring. The docstring tells us something about the function. So this is a string, which, you can type anything you like in it. You also do not have to do that, but also from a best practices point of view, it is best to write it, because you might create a function that now you know what it's doing, but in 3 weeks' time you don't know anymore what it's doing, and hence writing these docstrings are essential actually for your own work, I would say. In this case, 3 double quotation marks, which gives us the possibility to write some information about the function in multiple lines. But you do not necessarily have to. Another possibility is that you just use one double or single quotation mark, which represents the fact that you only can write something out in one line. So that's a lot of information about how the functions are created. And then I think it makes sense if we have a look at some examples. I'm going to make it a bit bigger, so that's maybe a bit nicer to look at. Okay, so yeah, I will give examples, but there's still a lot of theory we can say, so I will do that as well now. In this case, we're creating a function which is called myAppsFunc, which represents that we're going to create a function that will calculate the absolute value of an integer. Okay, so we start with the def keyword. We're defining the function named myAppsFunc, and it accepts only one argument. We're having some information about the function in one line in this case. So myAppsFunc takes a number as input and will return the absolute value. Okay. And then the only code that we're doing is this. If that value that we're giving the function is lower than 0, then we're taking the opposite of that value by taking the negative of a negative, which evaluates into something positive. So we're rewriting some value, overwriting some value to something positive, and then returning that value. Okay, I hope that makes sense. And I've just run the function, and you can see that because there is now a 1 in between the square brackets next to that cell. But you can also see that nothing happened. And this is what you can interpret as we're telling Python about the function. To be a bit more detailed and specific, now we've actually only told this notebook that we just created this function called myAppsFunc. Why am I stressing this? If I would open now a different notebook, for example, files again, that function will not exist here. So we will have to create it in this notebook as well if we want to use it there. Okay, it's a detail, but it's kind of an important detail as well. So we've just told this notebook, we've told Python that we've created a function that does exactly this. Okay, so we can call a function using its name followed by rounded brackets. This is the same as we would have used the print or the length function, which are Python built-in functions. So now there is not much big of a difference. Indeed, in this case, you cannot, it doesn't light up green because it's not a built-in Python function. Also, maybe small detail. If we run this, however, what we get back is an error. And well, we might have expected it because we've created a function that accepts one argument, and in this case, we're not giving it any argument. And so the error that we get if we read it is also that this function is missing one required positional argument. Okay. It looks like we need to give it this exact argument, but that's not the case actually. I didn't stress that. It's not because of we defined a function with an argument called some value that the variable that we need to give that function later on in our scripts also needs to be the same variable. So that is not the case. This is just some way of defining the functions, arguments, and referring to it in the code block underneath it. Okay, so we can just give it the value -5 directly, and if we run this, the output in this case is 5. So yeah, now it's working. Okay, so what did I mean with what I was just saying with the sum value? If I would say sum value is equal to -5 and then run my apps func on sum value, this will indeed work, but I might as well have called it new variable and then here use that new variable, and that will also render out fine. Okay, so we do not need to use the exact same names of the arguments with which we define that function. Okay, there's a lot to take in, I guess. Yeah, earlier I didn't all discuss it into detail as much as I'm doing it now, but basically, let's say over the times that we gave this course, these came up as questions, and hence I'm already discussing it now. Okay, so we've been referring to the help function before. Yeah, I'm just going to run it and then you will see. What we get back if we run the help function on our own created function is exactly the same documentation string that we've defined here in the first line. Okay, can you see this? My absolute function takes a number as input and will return the absolute value is exactly the same as we're getting back here. Okay, so imagine that you're somewhere in your code and you don't know anymore where you defined that function and what it takes as arguments and how it works. If you've defined it in a doc string properly, then you can just quickly call that help function on your function, and then you will get returned that information on that function. And then, yeah, just to shortly highlight the fact that we've just recreated one of the Python built-in functions. Okay, so that's, I think, most of the theory for now as to how we create our own functions. Something else which I wanted to stress is that I will show it here. Maybe let's use this code. Let's do some live coding here. So we're defining that function that accepts some function and arguments as arguments. And yeah, let's call it A, B, and C. So 3 arguments. And we're going to do the multiplication of B and C and add A to that. And that will be the results. A question for you is name of my function, and I'm giving it 1, 2, and 3. The result is 7, right? This is correct. As if Python tells us it's correct, it will be the case. My question to you now is, if I would run this cell, if I would ask Python what result is, what will be the output, do you think? What is result at this point? Nice. Yeah, I guess that the people that are giving the correct answer have some experience with programming, maybe. So basically what's happening in this case is we're giving the function some values and it does some calculations with it, but it stores all of the variables in a temporary variable. Okay, so result is a temporary variable in the function when we call it, but it will not be accessible without, well, outside of that function. Okay, so that's very important. Result does not exist at this point. So after we've have the result here, yeah, result doesn't exist anymore. So what do we still need to do if we want to go on with the result that has been given by that function? We'll have to assign it to a new variable. And I'm thinking something else than results. New calculation. It doesn't really make sense, I'm sorry, but in this case, we're going to store the result of this operation, of this function calling. We're going to store that in the variable new calculation. And yeah, we're not asking something back from Python, so it's not giving us anything. If I would ask for what the value of new calculation is, that is indeed 7. So now in our script that we might be doing here on this, in this case, we can use that variable again. Okay, and still result doesn't exist. If you want to read further on that, local and global variables are the terms that you need to use to read more about it. Yeah, one other reason why we use functions a lot is to make it more readable. Imagine that you always retyping a line of code to do something. Sometimes it makes more sense if you just create a function from it and give it a name that makes sense, at least. So every time we're now going to use the function getMeanValue, we can expect that we're going to take the average value of, for example, a list. Whereas if you would always type this, then we need to think what's happening here, right? Okay, so in this case, we're creating a function called getMeanValue, and it accepts one list of values. Okay, so it's a list of integers or floats. And then we're creating a temporary variable in that function called meanValue, which takes the sum of all of the integers, or at least the values within that list, divided by the length of that list, which is the mathematical expression for calculating the averages. What we return to the user is that outcome, the mean value. And then we're immediately testing out that function within the same cell block on a list which contains the following integers. If I run this, what we get back is a result. Maybe if you go through other people's codes, what you might also see is that they do something like this. This is also a possibility, because in this case, we're just immediately returning the results of this operation, of this calculation, which is also fine for Python. Okay, so there is no need to first store it to a variable, and then returning that variable. We can already do it immediately. I usually tend to use this approach because for me, if I later on need to reinterpret my own scripts, it makes more sense for me to read this. The more advanced Python programmers maybe will immediately return it, the calculation of this, because that's less lines is sometimes more wishful. Okay. Another example of calling that function. And then stressing again, that's good practice to add a docstring, but we already mentioned that. But another thing that I'm highlighting here is that we can use functions within functions. Basically, Python allows us to have a lot of flexibility, and this is obviously also one. So what's happening here, we're going to compare multiple means of values of lists with values at least. Okay, so we're defining a function with this name, which has, okay, that's the mailman. It accepts two lists of values, and the first thing that we will do is get the mean value of each list separately and store it in two temporary variables. And then there is some if, elif, else statements, conditions. More specifically, we're going to compare the results of these operations. If the average values of those lists are equal to each other, then we're creating the output text like this. The mean values are the same, and we're also, because of it's an F string, we can return a variable within that string. So we return the result of mean value list 1. If it's not equal to each other, then maybe mean value list is larger than mean value list 2. In this case, we're going to say list 1 has a higher average than list 2, or otherwise it will be lower than, and then list 2 has a higher value, average value than list 1. Okay, and then what we're returning is the text. So we're telling Python about the function, nothing happening. Something is happening when we're calling that function with two lists of values. So basically, what happened, we called our own function that we created earlier within a new function that we created here, and then we can just call this function, and it will still work. So that's one of the flexibilities. Obviously, it's also possible to call a function within, for example, an if statement. In this case, we're checking whether the value of the average value, the average of the list of values, the average of a list of values is higher than 26. And if that is the case, we can print out this line of code, for example. So this is also possible. Okay, so I think I've said pretty much the fundamentals of functions at this point. If there are any questions, always welcome. We will first, I propose that we make at least one exercise. If it goes fast, then we can also have a look at the second exercise. After that, I'd like to show you a bit more details, a bit more advanced stuff that you can do with functions. And that's actually everything which I wanted to highlight regarding functions. So imagine that you're very, very, very fast. Then you can have a look at the project exercises, which at this point, at least if you're on the predefined schedule, are just trying to, the scripts that we already wrote, trying to rewrite that in functions. And the idea is that we then, just by calling all of the functions, we can redo the whole calculations at once. I'm talking too much now. Let's have a look at the exercises. If you have any questions, if you're stuck, if you don't know how to tackle them, just ask us here in the chat or privately. I will type in the chat the name of the exercise, and then please thumbs up if you're done, then we know how far everyone is. Oh, again, yeah, it would have made sense if I very shortly described what the Hamming distance is. So basically what that Hamming distance allows us to do is compare two strings with each other. For example, Caroline and Catherine. Did we already mention it here? I have it somewhere in the back of my mind and already discussed it. Anyway, given two strings, for example, Caroline and Catherine, I'll put them in with quotation marks. It's going to check, yeah, the Hamming distance. So it's going to check is whether the letters are the same, and if they are the same, it doesn't get a penalty score. For example, it's 0. So K and K are equal to each other, A and A are equal to each other, R and T are not equal to each other, so it gets a penalty score of 1. O and H are also not identical, and L and R are also not identical. So these all get a 1 as a value, and then I and N are the same, so there's no penalty score there. And so we add all of the differences. We take the sum of all of the differences between the string, which results in this case in 3. And so this is the Hamming distance in a very pragmatic way explained. So we're trying to find how similar strings are actually. And the more they resemble each other, the lower the penalty score, so the lower the number. Exactly, so it doesn't do any frame shifts. If you would do A, B, C, D, E, and B, C, D, E, F, it's literally going from the left to the right. So first one is not the same, second one is not the same, third one is not the same, fourth one is. So it's all not the same. So I agree, arguably, if you're really looking for, yeah, if you're looking at sequences, then you should do something like this, which then aligns the sequences more nicely next to each other. And then results, yeah, in a different result. But that's not what the Hamming distance does. It just checks two strings right next to each other.
Hmm.
I'm going through the solution of the people that posted it in the chat. So yes, Georgia, indeed, you can, if you're willing to share the solutions, that's good. Then you can see how other people have done it, which is always learnful, I think. And you could also, yeah, I'm trying to read all of them and give any comments. And I think I will use the one of Sophie as a solution because, yeah, there is something in her solution that I want to mention as well. I'll give it some more time though, don't worry. for the sec. I have to check if I'm not muted. No, I'm not muted. For the second exercise, we've already written code that you probably can reuse for this, right? So it's fine if you reuse that code, so don't start with the basics again, I would say. Like, don't start with the beginning again if you already have it. If you yeah, I'm going to write the answer to the question in the chat. Oh, nah, that's better. So Veronica, to answer your question, what you have to do in the Discord chat to have it in that nice layout is this. As soon as you type that, it will convert into like coding layout, and more specifically the code layout of Python. And then you'll have to end again with the three things. Some code here. It's difficult to type it in the chat because it will always render to code and you won't see it. The character is very specific though. It's not like it's this thing that you see a lot in French language. So it's something else than this. I'll leave it. What's it called? Accent aigu? Aigu. No, it's the opposite. Accent grave. That's it. Okay, I'm yeah, sorry. My program keeps asking me for strings. It says I did not define them. Ah. Yep. I'm going to answer your question like this, Sylvia, if that's okay. So you're defining the Hamming distance function with two arguments. And remember that Python is capital sensitive. Capital S string 1 and capital S string 2. And you're not using those arguments in your function, because in your function you're using with small letters string 1 and string 2. So that's something that goes wrong. But besides that, also you're defining variables within the function. This is possible, but it's dangerous, especially, yeah. I mean, you can do it if you're thinking about the gravitational air velocity, or what's it called, like 9.81 square meters per second, like these standard variables. But it's dangerous if you're trying to do it with the arguments that you might want to use later on. So basically, don't define the variables that are supposed to be your arguments within your function. And yeah, no, okay. So I thought there was also something wrong with the indentation, but that's maybe because I'm copy pasting it yeah, here in Discord. Okay, so the indentation still is not correct, I think. It might be. Okay, and I'm losing track of time. It's already 11:05. What do you say if we have a break now until 20? Let's say a minute after 20, and then we start to go over the solution of the Hamming distance exercise. And feel free to still keep pasting your solutions in the chat, and then I don't know, I can have a look at it. So let's say break until 11:20. I'm also in the chat pasting a poll. I think it would be better in the schedule if we have a break from 12 to 1, but we've been doing 12:30 to 1:30 before, so maybe you have other plans from 12:30 to 1:30. Just let me know if one or the other fits you better. Yeah, and with all of the stuff in the chat now. Don't forget to scroll up if you're looking for something. Let's see. So it's already, once again, checking whether I'm not muted. Okay. It's already 11:21, I see now. I told you that I was going to use Sophie's solution. Eventually there were other people with similar type of solution, so I could use someone else's as well, but I'll start from this one. Okay, let's do it differently. Let's put it there. And then string 1 is equal to hello, and string 2 is hello. Okay, whatever. Why did I want to use this one? I'll first explain what's happening here. So we're defining a function called Hamming distance that accepts, I'm not sure if this is going to work, apparently it did. Usually you do not have any spaces in between there. It's conventions, I'd say. So defining the function Hamming distance, and as arguments it takes string 1 and string 2. Let's ignore this for a second. What we're doing then is we're checking whether the lengths are the same. If they are the same, we know that we can compare both strings with each other, and then we can do it, for example, with the zip function. If you remember this, we can use the zip function, which will, with the for loop, pick up for A and B each separate character from string 1 and string 2 at the same time. So, okay, the first time A will be H and B will be F. The second iteration, A will be E and B will be E. The third iteration, A will be L and B will be L. Okay, and so forth. So then we can do this if statement. So if A is not equal to B, so in the first case, if H is not equal to F, that's true, they are not the same, then we add 1 to our counter. And therefore, the count variable in this case needs to exist before we can do such an operation. And that's why in the beginning, in the first line here, well, second line, we assign the value of 0 to the variable count. So that's a lot of if and for and ifs. Yeah, but it works. So if this, let's ignore this for a second, the return here. Imagine that the lengths were not the same, then we would not do anything of this, but we would instead immediately go to this else statement, and we would return, in this case, none. I'm going to clean up the code a bit because now I have a second look at it. Might have been a bit nicer. So I call the Hamming distance function now with the strings that I just defined, string 1 and string 2. And the result in this case is 1, because only one letter here in both strings is different. So that's behaving as we expected. Imagine that the strings are of different length. Let's see what happens. What we get back is the value of the string none. And so that's what's happening here. So we have an if and an else statement, and depending on the outcome of the first string, the first condition here, we're either returning the count value here or we're returning the non-string. And that's something that I thought would be interesting. So depending on different conditions, we can return a different value to Python. So we can have that like here within the code. I'm scrolling down. Yeah, there is one else more. Okay. If we were to clean it up a little bit, we could have a doc string here. That looks okay. This is fine. This is good. This is okay. This is good. We could have done something like this as well. Else count is equal to none. And then return count. So we set the variable count to 0 in the beginning. If the lengths of both strings are the same, then we will calculate the Hamming distance. So every letter that is not equal in the both strings will result in an added 1 value to the counter. In the other case that the strings are not equal to each other, we're overwriting the variable count with a non-value. So, and then we return the count variable to the user. So in this case, string 1 and string 2 are not of equal length. So the result of Hamming distance will be none, and we will literally see no. Yeah, I first need to run it. So we will literally see nothing as an output. Imagine that I would store it into a variable called result, for example. And then I would ask for, let's say, I'm printing out the data type of result. Then we can see that the data type of the variable result is of the non-type. Whereas if the strings are of equal length, we're just adding values, adding 1 to the counter, which will then result in count being an integer, 0, 1, 2, 3, 4, or something like that. And then hence the data type of result is an integer. What is it exactly? In this case, 1, as we've defined before. Other solutions used this approach. That's also equally good. We need to do something like this. String 1 A is not equal to string 2 A. Let's see if that, yeah, that's good. So another possible solution was to check how long the string was. If they are both from equal length, then you could say that whether you write here string 1 or string 2, it doesn't really matter because the length is the same. So you're checking out how long they are, and then you're creating a ranging object going from 0 up till the length of the string. And then A will then pick up the values 0 in the first iteration, 1 in the second iteration, 2 in the third iteration, etc. And then we can use that value to slice out a character from that string. So slicing out in the first iteration A is 0. So we're slicing out index 0 of that string. Same for string 2. And then the result of this operation is the first letter, the first character. So H for string 1 and F for string 2, which are not the same. And then we add 1 to the counter. And that we do for every letter in the string. Two different methods, equally fine, I would say. I will check your solution in a second again, Xavier, and then we can find something that works. We can come back to this exercise, or we can have a look at the project exercise maybe after I finished the last explanation that I wanted to do here, which we called variations on arguments to functions. So this is a bit more detail, a bit more of flexibility that you can add to functions and how it accepts its arguments, which might be interesting for the code that you might write at a certain point. So there is two different things that I would like to show you. And the first thing is, imagine that you have a function, that you're creating a function, and it needs to accept some arguments, but you're not sure how many arguments exactly you're going to have. It depends on a specific situation maybe, and it can vary the whole time. If such a scenario is the case, then what you can use is the so-called unpacking operator, which is this asterisk. And you would use this asterisk in front of an argument. If you write such a thing, this will be interpreted by Python as, well, yeah, there can be a number of arguments, but we're not sure how many. So it could be one argument, it could be 2, it could be 3, it could be 4, etc. So if you're doing such a thing, you also need to be 100% sure that the code written in your function is able to cope with this variable amount of arguments that you're giving. What do I mean by that? And let's have a look at this example here. So we're defining a function called mean value this time. And we're giving it a flexible number of arguments. Some kind of docstring, some information about the function, good practices. And then what we're doing is we're making an iterator. We're going to iterate over each argument that is given in that function. So now we refer to value list, which is exactly the same argument as we've given in the definition of that function. So if there is only, good point actually, if there is only one, it's not going to work actually. I didn't think about it this way. Okay, so it needs to at least have 2 arguments in this case, because here we're making an iterator that will iterate then if there are 2 arguments over each argument. So for each list in value lists, we're going to, given that it's a list of numbers, pick up this, calculate the sum of that list divided by the length of that list, which is the average value of all of the integers or floats in that list. And then, given that we have 2 lists as arguments, we will have to do that twice. So we will probably want to store each calculation in, store it somewhere. So that's what we're doing over here. We're first creating an empty list, and for each average value that we're calculating, we're going to append that mean of lists. So that average value, we're going to append that to the list mean values. Okay, so the first iteration, it's still empty. We're just going to add it to that list. Second iteration, there is one value in there. We're going to add another value to it, etc. And then we're returning that variable that we created. Okay, so running, nothing happens. Just telling Python that the function exists now. And now we can call it for the 2 lists here. I hope it's clear that you can see them like this: 1, 2, and 3, and 4, 5, and 6. And if we run it, what we get back is a list with 2 values, and the 2 values are the average of the first list and the average of the second list. And the same is valid if we would do it for 3 arguments. Now what we get back is yeah, a list with 3 values, average of the first list, second list, and the third list. Now I'm curious if I run it with only one list. Ah, it does work. I would have expected that. Yeah, but you can iterate over a list, I guess. So yeah, does make sense in the end. Okay, not important. If you were at, yeah, to use this unpacking operator on arguments, it makes sense that you read a bit further on it, because Python is a bit picky of where exactly you write it. Okay, so if you can have arguments in front of it, argument 1, for example, and then followed by a number of arguments, a variable number of arguments after that. So this might be possible, but the other way around might not be possible. So Python is picky about it. So that's one flexibility which you can have in functions. Another one is keyword arguments. And we're building further on the function that we created here. So we're reusing that code here. So we're defining a function called mean value with any number of arguments defined first. And then we have something new here. We're having an argument which we already give a specific value, in this case a Boolean value of false. And then this is exactly the same as what we did earlier. We're going to calculate all of the mean values of the lists that we're giving here in the beginning. And then we're going to do the following, which I'm highlighting here. We're going to check if sorted list is equal to false. And if that is the case, yeah, we're going to print, I calculated all the mean values of your list, however, I did not sort them. Whereas if sorted list were to be true, we're going to do one more operation on our newly created list here, mean values. More specifically, we're going to sort them. And then we're printing out, I calculated the mean values and I also sorted them. And then what we return is the variable mean values. Okay, so in the case that sorted list is equal to true, we're going to sort all of the values within that list. I'm going to run it and then give an example which will make more sense. So different options that we have now. We will always have 3 lists. In the first case, we're going to tell our function that the sorted list is equal to, so this variable is equal to false. Okay, so we're explicitly setting it again to false. And what we get back is, why does Jupyter do this? What we get back is we're printing out that line that it calculated all of the means of the lists, but we did not sort them. And what we get back is indeed, yeah, a list with unsorted results of those lists. Unsorted results being the average values of that list. However, we also do not necessarily have to specify that keyword, the sorted list variable. In this case, because of we defined it as such, it will take false as a default value for the variable sorted list. So what is going to happen here? Well, actually exactly the same as what we did here, because basically nothing changed in between those two code snippets, let's say. It is going to be different though if we explicitly set the sorted list variable to true. And in this case, then we're going to this else statement in the function, and we are going to sort the values in the mean values list. So in this case, now 25.5 is the first value, followed by 27.625, and then 27.75. So basically, this is everything I wanted to tell about functions. I think this is quite an extensive explanation of all of the things that you can do with function, especially the last section here on keyword arguments and yeah, a variable number of arguments that you can give a function. Do I use it often? Not really, actually. The last one, the keywords arguments, is kind of nice if yeah, you want to do specific things depending on different situations. So I would use this a bit more often than the first one. But yeah, once again, sometimes I think it's nicer if you follow this course that you have an idea of all of the things that you can do, because that will help you more than if I would not say it. Anyway, let's I would propose that we still have a look at this second exercise, because I think it's a decently interesting one. Let's say another 15 minutes. So sometime before 12, I will go over the solution of this exercise. And then we can maybe already say something about modules. Yeah. So this is actually already quite, I think at this point we're arriving at a stage that we can already write nice scripts ourselves. If we have a FASTA file and we can read it in and calculate GC content, or if we could, yeah, from here we can actually think about much more possibilities that we can do. I think it gets decently interesting at this point. I leave you to it. So sometime before 12, I will go over the solution, and I will keep an eye on the chat if there are any questions, or if you share your solution there, I will also have a look at it. big. Oh, this is terrible. So yeah, I'm going to have a look at your solution in my notebook. So maybe you can follow along. So if I would run this, indeed, we're getting an error. Ah, oh, that's a pity. So this is indeed the correct expression that you would need, although the exclamation mark needs to be in front of it. Let's see if this works. Name Boston is not defined. Nope. We need quotation marks. We need to say that these are strings. And this is working. That's so often the case that it's really silly small mistakes, and you can even search hours for the solution, even though it's right there. I'll share it in the chat again. Hello again. So I don't think we will talk about modules still before lunch. So I can imagine, well, yeah, it's not really fair. I've seen the exercise a dozen of times. I created it myself, so I know exactly how to tackle it. I can imagine at this point it's a lot to tackle, to interpret, and to write in code. So maybe it makes sense if we go over the solution together, and I will do that in a very detailed step-per-step way, and then you can follow my thinking process. And if I do it in a very detailed way, it will also take a long time. So if you think you can find the solution on yourself, then maybe mute the audio. So yeah, you can mute me or put a YouTube video on stop, and then you can go ahead and find your solution, and I will just do it here for everyone before the break. And then once we're finished, I guess we can have a break and we just see each other back at 1:30. It's a long break then. So yeah, at this point there is many possibilities. The one that Veronica now posted in the chat is a very nice one, arguably better than the one that I will show you now. But yeah, that doesn't really matter. If it works, I guess it works. So what I will do now is I will first write all of the code as we would need it, and then I will rewrite the code into a function. That's usually how I work, because I'm never 100% sure of how your code will work and what it will give. And then it makes sense for me that I first discover all of the lines of code that we would need inside of that function, and then write it into one function once we're sure how it will work. So the first thing that we need to do is we need to read in that FASTA file. So if we still remember well, in the previous chapter, it looked something like this. We open a link to that file as a file handle. And then we can, for example, we did it earlier actually in this manner, and I will do it again. So we will read in all of the lines together. Because if you look at the file, it's called gene.fasta, gene.fa. It looks like this. It's not really big of a file. I'm not muted, right? No, okay. It's not big of a file, so we can just read all of the lines in at once and then into a variable, and then use that variable again. So we could do that. Yeah. So we're storing it in the variable lines. At this point already, let's see how that looks like. It looks like this. And then we can separate two cases. Either it is the header or it's part of the sequence. And that's where we suggested this starts with method. So if we say, we can extract the first line from the variable lines as such. So we slice out the first line with the 0 there. The second line is then this. The third line is then this, etc. So actually it's better if we do it as like this, for each line in lines. So this is an iterator which will iterate over all of the lines in the variable. lines. And then we could say something like if that string starts with that symbol, we know that it's part of the header, and if it's not the case, it's part of the sequence. Fair enough. So if line starts with that, so that will evaluate to either true or false. If it's true, we're going to use this as a header. If it's not the case, then we know that it is part of the sequence. Let's say add that line to the sequence. So because if I printed this now, it's not really clear anymore, but it ends with a new line character represented by the \n. \n is, if we would count all of the characters in this line, if we don't strip it out, it will count as a character. And so the length will be, the GC content will be different because of these characters are in the sequence. So we need to make sure that they are being removed. I'm now focusing on the sequence. Strip is the operator that we use to remove all of the white spaces in front and at the end of a string. So we use that on a string, and in this case the string is still the line. Once we do that, we can store that line, so we can store this string. First could be this one, for example, or this one. We're going to add that to a variable in this, let's call it sequence, which will then contain the complete sequence. Every time we try to use such a type of operator, the sequence variable already needs to exist in the first place. So that's why we need to start by predefining that variable, and yeah, it needs to be empty in the first case. If we look at the header, we already have seen a similar thing. We could say the header. So if the line starts with this symbol, then we know it's the header. What do we need to do if we want to store it and or reuse it? Let's say that we just want to remove that symbol here. So for this we would do line. We slice out all of the values except for the first one. We ignore the first one here. Let's call this temporary header, because now at the end of this temporary header there is still a white line character. So let's see. Yeah, the real header is then temporary header, and then strip all of the white spaces. Okay, if I can do here print header and see how it looks like. And I could do here print sequence. Let's do it different. So I'm often also using print statements here and there, especially at least in the Jupyter notebook logic, just to see how the variables look like at that point. And in this case, like I said, I already know where we have to go, so this works. The header is the first line here, and the sequence is all of these lines. Imagine that we did not do the strip here. I'm going to rerun. So for some reason it is not there. Yes, it is, but you cannot see it. Okay, I thought so. So what is happening if we do not strip the white spaces at the end of each line? Then we still have this new line character there. And yeah, I might be wrong, but I think at least that these will cause minor variations if you calculate the GC content. Minor, but very important, possibly. So it's, yeah, if you just ask for the variable back, then you get this. Whereas, if you would print it out, the new line characters are interpreted, and then the sequence is being, there is always a new line printed out on a new line. So, small but very important difference. So given that we strip it, then we indeed have the header and the sequence. And now that we have the sequence, let's see, sequence.count. We can use a count method to count all of the C's, for example. 409. We can also use the length function to check how long the sequence is. 1231. Wow, that's a high GC content. Yeah. It will be okay. So we need to use these type of expressions to count the C's and the G's. Yeah, and then we divide by all of the characters, the length of the string of the sequence, to get the average GC content. So sequence.count G plus sequence.count C, and that we will divide by the length of the sequence, and then basic mathematics, put this in brackets so this has precedence. Then let's store that into a variable GC content. And that we can bring back one level, and then let's ask for the GC content 63. Let's multiply by 100, then we have a nice percentage sign. Voila. Is that? Yeah, it's correct. Because it rounds upwards, right? Yeah. Okay, so this is what I usually do. I make something that works, and now I translate it into a function. Arguably, that's not the best approach, but yeah, that's just how I work. So the function that we will need to write needs to have one argument, namely the FASTA file itself. So what we can do is I select all of the code block, and then I use my tab key on my keyboard, and that will place everything one indentation up. Why is that necessary? Because now we're going to define a function, GC content, and it accepts one argument, and as soon as we yeah, the content of that function needs to be in the indented code block, of course. So that's why I'm writing it here in one indentation up, and that's why I moved everything also one indentation up. Function starts with defining its name and arguments that it needs as an input, and returns an output, in our case the GC. Let's stick to the GC content for now. And then yeah, then we need to make sure that we change the content of the code so it accepts the arguments defined in that function here. Okay, so basically what we need to do is we need to remove that and change it by the argument that we will give in the function. Because if we will call the function, it will we will do it as such, gc content on data.gene.fa. Okay, so we will call the name of that file as an argument to that function, and therefore we can remove it here, or we have to remove it here at least. And then usually I check to be sure that we're not defining any other variables, but it's not the case. Okay, so this should be fine. And it is. And then actually the question was to create this sentence. Let's say that we still return the GC content, but now we print out with an F string because I want some flexibility in there. This value needs to be replaced with the value that we're calculating, so GC content. That doesn't look nice. So there are... Sorry, this is not good. Yeah, this is better. Yeah, so the formatting layout options, 2 decimal points after the comma, and then it's a floating point number. GC content, yeah, that's the function itself that I'm calling. It's GC cont, the variable that we're calculating here that we need as an output. So that works better. Oh, and we can still then say %. Voilà. That looks better, right? And now we could also, actually we didn't mention that yet. We could also return the header as an output. We can have multiple outputs, obviously. And this is how we can do that. So a comma separated number of variables here. And what we get back, if we just call that function now, well, it's printing out that line as we ask it to do. But what it's also giving us is, in this case, well, it's always a tuple, and in this case it contains 2 outputs. The first one is the GC content itself, and the second one is the header, how we have defined it in the code here. So now we have 2 different arguments, 2 different outputs, sorry. Imagine that you want to do something with it. Then you could say something like this. Results and header FASTA. I'm just using explicitly different variable names. So you see that now we can do other things with either the GC content or the header string. So here it's important that if the function gives you 2 outputs, that you can assign them to different variables, but you also need to make sure that you also give it 2 outputs. If you only give it 1, for example, then you will store result. Now, then you will get back the tuple. But if you then, for example, try to something else as a third output, yeah, that's not possible because we only defined 2 outputs in the function, and now we're trying to access 3 outputs. This is not possible, and hence we will get an error. I'm sorry, I'm deviating a lot, and yeah, hope it kind of makes sense. Trying to show something else, some of the errors that you might get if you're trying to create your own functions and stuff like that. Let's remove this. Okay. That's I think enough for now. Let's have a lunch break, I would say. I will keep an eye in on the chat. If someone else still wants to share his or hers solution, and then yeah, I will give my comments on that if necessary. And yeah, we go on after the lunch break. So break until 1:30. Yay. I can definitely scroll up so you can see the code, but I'm going to share it. That would be nicer, I think. Hey, James. Okay, so hello again, everyone. Hope you had a nice lunch break. James is or was here at least for a second. Yeah, let's say due to inconveniences, he's not here today, but that's okay, I think. I think I'm still managing the chat fine. If that wouldn't be possible at a certain point, or you would have questions for James specifically, and he's not answering them in a private message, for example, yeah, please send them to me, or he'll look at it later on. So this workshop earlier used to be 2 days, now it's 3 days, which means that we have plenty more time to do these exercises, but probably also means that we will finish earlier. So modules is a decent chapter on its own, also not very long. And then there is just the plotting chapter, which from where I want to show a couple of things. But that's not going to take until 5 p.m. So I'll get started in a second, but let's say that we finish earlier, and then I will definitely be here the whole of the afternoon so you can work on exercises that we didn't finish or the project exercise, and you can keep asking questions to me. But yeah, if you maybe have other plans, or you want to make now already plans, maybe you want to go to the lab in the late afternoon, then that would be possible as well. So I thought that's maybe interesting to know for the people that maybe have other occupations. Without further ado, modules chapter, which I've already introduced in the morning, but let's do it shortly again. So basically now, before today, we've created sequential code, so blocks of code which we always copy pasted over and over again. Not always the best idea, hence the introduction of functions. Generally, we would say always try to make functions of your scripts, at least wherever possible. And yeah, well, you can always make your own functions, but you not necessarily have to do it all the time. So before lunch, yeah, I gave the example of calculating the average value. Doesn't really make sense that we make our own function to create and to calculate the average value if it already exists, right? Arguably, you do not know always where to find it. That's true. So I guess if you Google it, after some search, you will find it for sure. If you use a lot of Python, or if you use it a bit more, then you will start to know where you can find which functions. But so this brings us to the fact that Python has a lot of built-in modules, which are basically libraries of functions regarding specific themes. And I'm going to scroll down a little bit so I can explain it a bit better. Here we're going to have 3 examples of such a library, and there is one that you can use to do to extract the time, stuff like that. A lot mathematical functions are in the maths library, like the number pi and p and the square root, and the one OS, which I already mentioned, which can help you with creating paths towards a file and generally your folders, your local folders on your computer. But let's start with the beginning, and the beginning is probably the import syntax. So there is a lot of different nuances when it comes to how we can import libraries or modules. And I always have to check and to be sure that I'm not muted. It's annoying because there is a little button here on my controller which can mute myself, and I'm always scared that I do that. Anyway, there's a lot of nuances as to how we can import modules and hence the libraries within Python, and that's very briefly what I'm trying to show you here. So generally what you do if you want to import a library with a bunch of functions, so if you want to import a module, it's this line. If you're following along and you try to run this, you will get an error because this module doesn't exist. Okay, so don't worry, we'll fix it. But for now, let's just look at the syntax as such and not run it yet. So importing a module with the import keyword followed by the name of that module. This doesn't mean that all of the you can use all of the functions that are described within that module. If you want to use them, you still need to refer to the name of that module followed by the function itself. So basically, I don't know if I was clear on that. A module can contain variables, it can contain a Python script, and it can contain functions, and generally it contains a bunch of functions. That being said, so if you imagine that there would be a function hello in the module, then we would call that function by referring to that module. Okay, so we import that module, and then we refer to the hello function by using that module reference. So module that dot hello to call that function. But imagine that you use a lot of functions within that module, then you would always have to write module dot whatever. Arguably, some of you might find it cumbersome. You can make it easier for yourself, and that is by rewriting it as a different name. So we're going to import module, and every time that we're going to refer to it, we're going to use it as the letter M. So import module as M. And then we can use this type of syntax to refer to that module, or at least to call the function which is part of that module. Okay, and these type of naming conventions are very are used a lot, and you might have seen something like this before. So the pandas library, which I have mentioned quite often before, import pandas as pd, import numpy as np, import seaborn as sns, import matplotlib.pyplot as plt. You will see it always, like if you're Googling other people's code, or you're using other people's code, they will always use this syntax. It's not that you have to do it this way, but it's generally a convention. Every time that you would use pandas, you would write it, use it as such. So it's a convention. And then as a last example, if you do not want to refer to that library by using this m.hello, and you just want to call the function immediately, then you could also say something like this: from a module, in this case module, so from a module import hello, and hello in this case is a function, so this is also possible. And now we've imported that specific function from that module, and now we can just use that function as such. We do not need to refer to that module anymore. I don't know for sure if you already have enough background with this explanation to answer the following question, but just out of curiosity, can you already think, I have written it here below, but I don't think it's in your notebooks. Why should we try to omit this? And can you think of any examples where this might go wrong? So by importing specific functions from a specific module and then using that function as such and not referring to that module anymore, it's not necessarily a bad idea, but it's not always the best idea. The question is, can you think of any examples where it might go wrong? And I will try to ignore the chat for a second, and then let's change this syntax, or at least I will always create new cells underneath them, and then I will try to make them work. And how we will do that is because in our notebook, in our folder with all of the materials, there is a folder named modules over there. And if I open it, you can see that it contains 3 different files, and these are Python files. And these Python files can be imported as a module. So here in this case we have let's say it's a Python script and it's called module.py, and if we open it, you can see that it contains 2 functions: compare mean value of lists, which you might recognize from the previous chapter, as well as get mean value. So you can see that this code will not do anything because of the fact that we're just creating 2 functions, but we're not doing anything with them. So yeah, this module is not going to do anything. It's just creating these functions. Imagine that, okay, so you're doing a PhD maybe or some research, and yeah, you have two different projects, and each project has its own data analysis scripts or files. Imagine that you have this lengthy script analysis which you want to use in each project. You can define all of the functions that you need within one Python module, and then yeah, import these functions in your separate projects. And then you can always have like one Python script which contain the functions and which you use in both projects. And then you're 100% sure that if you change them in this one central location, that they also change in both projects. That being said, as a background, what else do we see here? The first line is maybe worth mentioning. This is called the hashbang or shebang line. Not really important as long as we stay in this Python environment here, in this Jupyter environment. So it's possible to create these Python scripts modules without this first line, but it might give you errors if you're trying to run it outside of this environment. It doesn't really make sense to go into detail about what the shebang line does exactly, yeah, because it's also not very important at this stage. But yeah, if something at some point goes wrong when you create your own modules, maybe think about the shebang line. Voila. And then you can always send an email to us to try to fix it. So I opened this notebook, 10 modules here, which is situated here in between all of these notebooks. And if I try to import that module, it's not working. Why is that? Because Python cannot find that file. You need to tell Python exactly where to find it. So how can you do that? Well, that module is actually part of this modules folder. The naming is not ideal here to explain it, but I hope you can see that we're referring to that module.py as part of the modules folder. And if we run this, now it's going to work. Okay, so imagine that this specific module is part of some faraway folder. Then you can refer to that like path to modules.module, for example, or shorter, just in this case, modules.module. Once we've done that, but I'll keep rewriting it, doesn't really matter. Now we can call that function get mean value. Not going very fast, and we give it a specific list as well, 1, 2, 3. It's not working. Name module is not defined. Oh. I know what's going wrong, and I'm curious if I can fix it like this. Okay. So in this case, you still need to refer to it with this lengthy method. This is not really ideal. So what you could do is rename it, and then it would look like this. Import modules.module as m, and then say m.getMean value. Generally, I have to say that you will use other people's modules or like community built, like Pandas, NumPy, Seaborn, instead of your own. So these are very specific things which you usually don't need to do yourself. But I'm just telling it here as for the sake of completeness. So here we can rename it as well as m, and then we can just refer to that function with only that m, this renamed module. Or as James says, we could also make it m1, for example, and then say m1.get mean value. That will also work. And then here, as a last example from modules.module import, well, let's import a specific function, get mean value. And then let's let's use that one. Voila, and this will also work. And then I saw in a blink of my eye the answer to my question is indeed as Paul, and I think I saw someone else giving the same answer as well, but I missed it apparently. So indeed, if in your modules you have similar function names, or at least more specifically the same function names, then yeah, then you do not know anymore from which module you're using that function, right? You can, I mean, if there would be a function called print for some reason and it does something else, if you now want to use the print function, then you will mess up your Python environment. So this is the reason why generally we just import a library as such and rename it, for example, as PD, and then every function which is part of that library, we will have to use it as such. And then everyone else that's reading your code can then see, he's using the function name part of the pandas library. Okay, what else do I need to say? Nothing exactly. No. Okay, so that's okay. Let's have a look at 10.2.1 exercise. There is a module named readFasta, part of the modules folder, which contains a function that reads in a FASTA file with an RNA sequence and returns the ID, description, and RNA sequence in 3 base unit chunks. Import this module in a cell and call the function on the file gene.fa, which is part of the data folder. Okay, so this shouldn't take too long. Exercise 10.2.1. Give it a thumbs up in the chat if you figured it out. And I do remember what I needed to say, but I'm going to wait with it. Okay, it's working for most of us. Yes, thumbs up if it's working out fine. Nice. That was a delay of YouTube, I think. There are actually a lot of possibilities. If you would interpret the exercise exactly, you would have to do it this way, I think, but as I mentioned, it's not always the best idea, so let's keep it as such. So let's just rename it and then give it the data gene.fa. Ah, um, yeah, okay. Yeah, the name of the function is different. Okay, so I got an error and I thought that this module didn't exist, but it does exist. It's just the name of the function that was wrong. Okay, so this does work as suspected. Can you recognize also how the output is given? It's these rounded brackets represent a tuple. So a tuple with 1, 2, 3 outputs. This is a long list with all of the codons. A very long list. It stops with that list and also the stop of the tuple here. So I'm scrolling up again. Yep. Some questions in the chat. What else could I do before I say I start answering them? You could say from modules.readFasta import, and this is where we could say import a specific function, but we could also do this. We could use an asterisk, and an asterisk would mean that we import all of the functions that are part of that module. Okay, but here again, we will then be able to use the functions as such, which is not always the best idea because some of the important functions may have the same name as another library function, and hence this can get confusing or it can result in unexpected errors or unexpected other results. What I did still wanted to mention, which is really important, it's you do not have to use this line every time when you open a cell. Once you've imported a module, once you've imported a library with a bunch of functions, in a notebook once, all of these functions will be then, you will be able to use that over the whole notebook. Okay, so generally what you would do is somewhere on top of a notebook, you would open a cell and you would say import blah blah blah, import blah blah blah, import blah blah blah, as blah blah blah. So you import all of the libraries that you will need in that notebook. So in the code that follows in that notebook. And then it's for everyone that reads your notebook, that reads your code, it is then clear which libraries you're using, yeah, and how you're renaming them as such. Okay, so generally all of the imports that you do are defined on top of your notebook and not, yeah, as we're doing here somewhere in the middle or every time in a cell again. And now I'm going to have a look at the questions. If the module would be located in folder 1, folder 2, folder 3, module.py, then I would need to import. Yes, it is true, then you would indeed need to import it as such. However, and I didn't really mention that. So that's how you're referring to if this module is in 3 folders away. So in folder 2, which is in folder, yeah, folder 1, then in folder 2, then in folder 3, and there is modules.py. You do not have to use this .py extension because Python figures it out by himself. He knows, it's module.py, it's a Python script. So yeah, you do not have to define it there. So this is indeed what you would have to do. Will we be able to access the YouTube videos after this course? Yes, they stay for a little while on YouTube. And whenever there is a next edition of this course, I will delete them and then they are overwritten with the new ones, as is the case right now. Is there a way to list all of the functions in a module? Yes, yes. Good question. I'm doing it here because then nee, let's see it. Yeah, I'm just finding a good example here. Import as rf and then rf.readfasta file. No, I need to do it like this. Okay, so now the question is, can we find all of the functions that are part of it? And yes is the answer, and you can use the dir function here as well. So if you would import modules.module, so this one had the functions get mean value and compare mean values, something like that. That's imported as such, and then use dir on m. Then also here we can see compare mean value of lists and get mean value. So that's how we can check all of the functions within a module. There was an extra exercise. Yes, so how can you create your own modules? Well, it's a bit silly in Jupyter Notebooks, but that is obviously because, yeah, you're combining a lot of text together with code, and it is possible to, I'm not going in detail. You can read all about it in the extra course part. So if you click this link, hopefully it doesn't exist anymore. So you go to the folder extra course parts, and there in modules, you can read about it, how to create your own module. It's not really difficult, but Python doesn't really, Jupyter doesn't really give you a straightforward way to to do it. Yes, and there is a question that I expected. If to get to the folder 1, folder 2, folder 3, module.py, you have to go back as in ... How do you specify that? So in this case, yeah, it's not necessary because our notebook is right here and the module is in this modules folder. So we do not have to go back one level in the folder structure, right? How is it possible if we have to do that? Well, I'm afraid I have to tell you that it is not that it is not possible. If you would like to do such a thing, then you would have to use the OS path trick, which basically, yeah. Let's say that it's also not very convenient that if you want to use your own modules, to have them somewhere very far away, as in go back one level or go back multiple levels. It should be convenient to find in one of the subfolders of the directory that you're in at that moment. Generally, you're creating a Python project, for example, and different parts of this one complete big project. There's different subfolders with maybe modules in them. So you're always, if you need to import modules, referring to one of its own subfolders, and you're not going back one level up. I hope that makes sense, less or more. So Python has a lot of built-in modules, and we're just highlighting here 3 of them, which you might be interested in using them, and just for the sake of the example, to show you how this would work. The first one is time, for example. There is no renaming convention in this case. So what you could do is just import the time library. If you then want to use one of its functions, and there are quite some functions. So we are importing time, and we're having a list of all of the functions that we can use as such. Now, if we want to use one of these functions, we refer to that library with time, and then we use a function. For example, ctime represents the current time, which is 2 p.m. This is some kind of system clock. This is interpreted by Python and your computer as a specific time, which is readable for us. But yeah, just as an example. And this is sleep. The sleep function will do for 10 seconds nothing. You can see the asterisk over here, meaning that it is still busy. And about now, we're done indeed. After 10 seconds of doing nothing, it will continue. Imagine that you want to scrape information from a website. There might be a block if you do it every second, or you're overwhelming the server with a lot of requests. Then they might block you. In this case, it might be an idea to install a sleeping timer, so it will do 10 seconds nothing, for example, or maybe a whole day, and then it will rerun. It will continue with the code after this timeout. So that's the time library, similar to, or something completely else actually, but the importing at least is similar, is the maths library. So besides the absolute value and the length of a list or something like that, which are built-in functions, there are not so many mathematical functions built in Python. They are, though, in the mathematical module or library. I use the terms mixed up, but they basically mean the same. There's a lot of more mathematical functions that you can use within that library. So, for example, the number p, using square roots, factorials, flooring, or sealing a floating point number. So flooring means that you will round it downwards, and sealing means rounding it upwards. Using power functions, 2 to the power of 4. Arguably, this you can also do as such. But maybe it makes more sense for you if you define it like this. Another example here is OS, which represents operating system. And it also has a sub part, namely os.path. But we import it just as such, import OS, and then it has a function getCwd, which represents get current working directory, and it stores it in the variable current dir. Now you can see, for me, in my case at least, and I wonder how different it is for Linux. I suspect that you would have different symbols here. So for me, this is, because of I'm using a Windows system, and Windows uses backslashes and double ones to create a path towards a folder. So the current working directory, starting from the C drive in users to your documents, Gentle Hands-on Python, January 2021. We can also, for example, use the function list directories on our current working directory to get a list of all of the files that are in our current working directory. So you can see all of the notebooks and all of the folders, data, extra courses parts, modules, project. What else can we do? We can make directories here. And I'm going to separate these 3 steps so it is clear. So first, we're making a directory, my temporary directory, and if I run it, it appears here in between my folders. I can also rename the temporary directory to my new temporary directory. Now it has changed here. And then I can also remove directories, and now it's also gone. Imagine that you have a script in which you want to import data from your file folders, in which you want to write out data in your folders. Generally, it's a good idea to use this library in which you create paths towards folders, because then you're sure that you're using the correct direction towards where you want to write it out. So os.path.join is going to create, we're giving it 3 arguments here, but it can contain any variable number of arguments, starting with the current working directory, followed up by a folder that's called modules and a file that's called module2.py. And this will be then created into one file path. Okay, arguably you could also do something like this. Yeah, you can just type it manually yourself. Like this. But yeah. This is more error prone than using the OS library. Okay. Continuing, there is also a possibility to check whether a specific file exists, and this gets interesting because depending on this outcome, you might say that if a file doesn't exist yet, you want to create a file in your script and then you can write out data towards it. So this is where it becomes interesting from a certain point of view. How big is the file? Yeah, it doesn't exist yet. So that's not going to work. If you were to do this, now it's going to work. So the size of a specific file can be given as well. And we can use the split function to split a path into the directory and the file name itself as well. This path contains backslash. Will it work in Python? If not, how to make it / format. So because of I'm running this, everything is running for me on my Windows computer. Which means that, well, Windows is using backslashes, and how I have to say it. If you would work on a Linux system and you also use this library, then the path that it creates, it's definitely going to be different, but it most likely also contains forward slashes. Because of that's how Linux works, and I believe Mac as well. And so if I would give you my code and you use the same way of creating the paths towards your files, and you're using Linux, it's going to be different, a different output here for you as opposed to for me. And this means that we can omit these changes, these differences between our operating systems, and the Python code will still work on your computer as well as on my computer, just because we've defined the path towards our folder, towards our files with this library, which takes this into account. Yeah. So Python indeed, how do I have to say? Python indeed uses these forward slashes to go towards a specific directory. That's true. However, if you think about the logic behind Python, so on your own computer, it's Windows in our case apparently, it uses backward slashes. Both will work if you use the OS library and you feed it to Python. It's taking into account that your operating system, but it will still, when it is passed on to Python, it will still transform it to the forward slashes that it needs. I don't really know how I have to explain it differently. I'm a bit stuck in my explanation, I guess. It works either way, basically. Yeah, I'm afraid you don't see it, but you're relieving me from my problems here. There is not, yeah, there's not really much I can say more. Okay, so these were some ideas of Python built-in libraries which you can import and then use to your likings. Obviously, there is also a couple of exercises. You do not have to make all of them. I'm thinking maybe the first one is the most interesting one because it uses the most of the libraries which we explained here above. So most interesting would be if you make the first exercise at least. If you're done, you can of course continue, but the first one is maybe the most interesting in this case. I'm sorry, I'm having a bit of fun myself in the chat. Jojo, you're referring to the indexing? Yeah, no, that's wrong, Jojo, indeed. It will sleep for 10 seconds and not for 5 seconds. I think at some point I might have changed the 5 to a 10 because then I have more time to show the fact that there is an asterisk and the Python is like waiting for 10 seconds before it does something. And with 10 seconds you have more time to say that than for 5 seconds. But I didn't change everything. I'll have to change that in the source code as well. Where is it? So I propose that I explain the solution which is in the solutions, and then yeah, because these exercises are going very specific and very detailed, I would say, and at least for me it would take a while before I would get the answer. After we go over the solution, we can have maybe a break and then come back to discuss plots. Or in the meantime, you could also have a look at what you already had for your solution and then try to make it work. And then you can paste it here in the chat and then we can have a look at it together. So I'll go over it, at least what I had. So we need to work with time and we need to work with the local folders. So I'm importing the two libraries that we can use for that, so time and OS. You can see that in the solutions, we do it like this with the comma separation. Technically, that's possible. Generally, we wouldn't do that. We don't do that. Then we want to create a directory which will then contain all of the files that we will write out. So the first thing that we want to do is we want to make a directory, so os.make directory, and we're going to give it a name, and the name is what we define here in the beginning. So the directory will be called time test. Then if we run it once, it will be fine. If you run it again, it will already exist. And then either it will give you an error because you cannot recreate that directory, or you will get an, you will overwrite it the whole time. In case you wouldn't want to get that error or you don't want to overwrite it, you can check whether the directory exists, and only if it doesn't exist, you want to create it. So that's exactly what it says here. We're going to check whether that directory exists, but we're going to invert it. So we're going to say if it does not exist, this directory, then we're going to create it ourselves. So that's what's happening here. And then we want to create 5 files. So yeah, you could write the code 5 times separately, or you can create a for loop from 1 to 5. So 1, 2, 3, 4, 5, for which we use a range function going from 1 up till 6. Once again, Python indexing starting from 0 is a pain in the ass if you look at it from this way now. So for E going from 1 up till 5, well, we will start with get the current time. We will and store that in a variable current time. We will create a file path first towards the directory and more specifically the name of a file as well. Since it has to change for each file separately, we need to come up with a smart solution of how we can create 5 different file names. You can automate it by using that I, which we create in the for loop. Alternatively, you could, in the beginning here, create a list with 5 files, and then you can iterate over that list and use that over here. So on the fly, we're creating the name of a file, which will be, for each iteration, be different. And this will be then the file path. So we have the current time and we have a file path. What we then have to do is we have to write something into a file. So the same way as how we would read in a file. So we start with open, in this case, the file path, and a W, which represents the writing behavior. Remember, by default, it's the R that is standing here, which is reading. So we need to be explicit and say that it needs to be in W. And we're using a file handle name called out file handle. And then we use that file handle to call the method write on, or the function write on. And then what we write out to that function is the current time. This is a very fancy way of doing that. The current time is actually going to be a string format. So it should be possible to, for example, also just write current time. Not 100% sure, but I think it should work as well. And then this is not being printed out into the file, but it's being printed out to us, to the user, by Python itself. So what are we going to print out? The fact that we have written a file with that specific path. And then we sleep for 2 seconds, which would be the last part. And then we go to the beginning of that for loop again. So once we've done it for one file, we iterate over the process again for the second file. So you can see there's a little hesitation here, 2 seconds every time before the next file has been created, and we print out this line here. And there is a folder time test now, and it contains 5 files. You can see that it has a name 1, 2, 3, 4, and 5. So that represents that I here that we appended onto the name of that file path. And if we open it, indeed, it also works like this. So you can see that it only contains one line. It contains one line, which contains the date and the time. Imagine that we would have done it with this. And now we're overwriting the files normally. The last one has been overwritten, so now we can open it again. I'll close that first. Now you can see it has 2 lines because of the new line character there at the end, right here. So that resolves in this second line now. I think, yeah, if you understand what I'm saying, that's already great. If you didn't find it yourself, that's okay. I think at this point, things get so very specific and so sometimes complex. What you really need to do is try to think about a problem that you have and divide it in separate sub-problems, and then try to tackle each sub-problem. And what I often do, if I don't know how to get started in such a sub-problem, like you need to extract a specific part of... Now, I will give a different example. If you would, for example, need to check whether a path already exists, and if not, create a directory, I would just Google it. And for sure, you're gonna find some answers on the internet. So that's really okay if you do it. All right, let's have a break until 3:05, if that's okay. And then we can come back and talk about plots as a last part. If you still want to share your code, feel free to do so as well. Yeah, Giorgio, hi. Um, sure, you can ask it in audio. Um, I'll keep an eye. Did you you're not in the Python stream thing. I'm not sure if I'm going to hear you.
Hi, Tor, can you hear me?
Hmm.
Yeah.
Yes, it's Federico, no.
No, it's because it's Giorgio and we are from the same house. Hi.
Okay, hi.
So the thing is that I'm trying to slice out the part of the code that is the relevant one.
Mm-hmm.
But so the idea is that in the exercise, I wanted to basically translate my sequence from DNA to RNA.
Mm-hmm.
And I wanted to,
Trans
do, of course, the complementary, right? So the codons, the complementary codons. I will paste the code so you can understand what I mean.
Yes.
So I found a workaround that is not pretty, but it works. And so the thing is that I had to basically translate the sequence from uppercase to lowercase of the opposite base, let's say in RNA, because the problem was when I had to change G to C and C to G, that if I do it consequentially, then
Yeah.
that I changed to G would go back. You get what I mean? So I wanted to,
Yes.
if there a way in which I can do replace of multiple things at once, because I cannot find it on the internet
So
either.
it's the first time that we actually include these project exercises, and either way, you do not have to do this, or I've completely forgot about this. Um, in the in the process from going from DNA to RNA,
Yeah.
Indeed, you're the eventually the process ends up the sequence will be still the same, but all the T's will be transcribed to use.
Yes, the thing is that since I was thinking that
But
since
you
translating the
don't have
code,
to do you don't have to take complementaries, because you would have to do it uh, twice. Hmm.
I can paste you in private the whole code I did if you want, but
Yeah, so basically in the project, it's not necessary to go that deep. I only thought about the transcription process is you actually just can keep the same sequence, but you in the transcribing process, the T becomes a U, and you can use the same sequence to translate it. And for this, you can use the library which is in there,
yeah.
and which goes over the sequence per letters of 3, and then gives you one amino acids letter
Okay, no,
back.
because okay, then was a misunderstanding of the exercise because what I did is basically translate it into the opposite codon
Mhm.
and then an RNA codon and see which one was not okay because it is a stop codon. So I basically translated the sequence to the complementary RNA and then I searched those codons into the sequence, into the library of
Yeah. Okay,
RNA codon.
I'm going to pull up a picture, and then I can better understand. So given that we have the sequence ATG8,
Yeah,
so the upper sequence, what you do
yeah,
is you take the complement of it,
yeah.
and then from the complement you take the RNA strand, which is then being transcribed. So that is another complement actually of this one, where you replace the A's with a U.
Okay, okay. I guess
Indeed, so
yeah.
biologically speaking, indeed, it's correct. But yeah, I was a bit shorter more direct, as in we can just replace the T with a U,
Okay.
and then you have the sequence which you can then use for the translation process here.
And then for the technical question in Python in general,
Okay, sorry, yeah.
I would like to change because in the code I pasted on the chat, my replacing is done consequentially.
Yeah, okay.
Is there a way in which I can do it at once? Because then every time I'm changing the same thing.
Do you
get what I mean?
do you want to answer on the general question or for specific transcription? I can tell you that there's
for the general code, just in case I need to do that another time for whatever else.
Okay, so in the case of here in the transcription process, I know this is not your question. There is a library called BioPython, and BioPython has a function transcribe and translate, for example. Yeah, transcribe is only relevant here. Or take the complementary, sorry, that's even more relevant now. And that will just give you the complement of a given sequence. This as a side note. But that still gives you the problem that indeed if you change your sequence, all the letters T to A, then you don't know which letters A in the subsequent sequence were from the T and which were A already. I need to think. Yeah, actually, I would iterate over all the characters in the sequence. And then check if it's an A, make it a C. If it's a C, make it, sorry, that's not true. If it's an A, make it a T.
Okay. So with
if it's a T, make it an EA. If it's a C, make it a G, and then else if it's a G, make it a C.
Okay. Yeah. So with a loop that goes all over
I think that's the only way how you can do it.
Okay. Yeah. Thank you.
Or you need to think about a one-liner that replaces. This is the best solution I can come up with now.
Yeah.
And should work.
That was the alternative I thought of, even though I had some problems coding it, so I said, okay, let's go for the dirtier way that works. Okay, thank you.
You're welcome.
Cheers from both.
Yes. Must be much more fun to do it with two than sitting alone behind your computer. Anyway, fine. Here you go. Mieke has given a solution which is how I had it in my mind. I can imagine. But if everyone is thinking along with the thinking process that we did right now, I'm afraid that we might run into problems when we get to the result of the project exercise. I'm not talking because so the sequence that you're given is, if you look at this figure, is the upper sequence, and the transcription from DNA to RNA should result in exactly the same sequence, just the T's have to be replaced with U's. Yes. Okay, so that's that, and then I'm answering on Giorgio's point. Indeed, if you look at Mieke's code, sorry, I was too fast. No, it's correct. Yeah, it's a bit different how I explained it. So Meekan is going to create an empty string full RNA sequence with, yeah, so empty, and then I'm going to show you. Allee. So starting with an empty string, which will then contain the sequence, the new RNA sequence, the gene is the DNA sequence, and we are iterating over each character in that DNA sequence. And then we check whether the first character in that gene sequence is equal to A. And if that is the case, we're adding the letter U to the full RNA sequence. And so it's not really replacing that we do, but it is creating a new RNA sequence string, actually. Yeah, I hope I don't think it's too much of a change that you need to do to make it work in the end. So I think that brings us to the last part, if that's okay, which before wasn't part of the workshop and which, my apologies, didn't really make sense for me, because in my opinion, if you want to analyze your data, at some point you also want to plot your data. So it would make sense that at least you have a notion of how you can create plots with Python. The most convenient, no. The biggest library, the one that already exists for the longest time and which is used most often, it's like the basic, the fundamental plotting library, is matplotlib. Yeah, the matplot library it represents, and more specifically, it's actually the pyplot, so the Python plotting library that we import and that we will always use as PLT. Okay, so anyone that's creating these which is creating figures with matplotlib will import that library as such. There are many other libraries, and I think you can have maybe a whole week course about just plotting libraries, so it doesn't really make sense to go into details here. I'll give you some tips when we finish talking about plotting here, as to where you can start reading on plotting libraries and stuff like that. So basically, what I would say is, first you ask yourself the question, what type of plot do you want to make? And then you search for a library which fits your expectations. And matplotlib is the library which has probably the most possibilities, because it's the most tweakable, it's the most flexible, and you can do really a lot with it. You can basically, anything you have in mind, you can do with the matplotlib library. But that a lot of flexibility comes also with a lot of complexity, I would say. So there's a lot of things that you need to think about yourself and your user when you're using the matplotlib library. That being said, if we want to, but it is okay. Sorry, I was reading in the chat, but it's not relevant. That being said, when we try to plot figures in Jupyter Lab or Jupyter Notebooks, depending on how the configurations are set, and maybe if you're plotting it in some other Python interpreter, you might need this first line here. Sometimes you need to be very specific and tell your interpreter that you want all of the plots that you will plot in your code to be, in this case, in line in the notebook, which means that basically all of the plots that we're going to make we're going to plot them out here within our notebook. Okay. So these are conventions. You usually first import matplotlib.pyplot and then matplotlib inline. And then let's have a look at some examples, right? So in the first case, and actually they have already been printed, but never mind. We're going to plot the numbers 1, 2, 3, and 2.5. So these are y values in a plot. And for this, we're using the plot function, which is part of the PLT. It's meaning in the same notebook. So yes, it's in the same notebook. Yeah. And then plt.ylabel, with this function, we can change the y label, which you can then see here. I'm rerunning just for the case. If you did not specify an x-axis in this case, so these are y values. If there are no x values, then by default it will take the values 0, 1, 2, 3 for each y value that is being specified. Okay, so that explains the point 0, 0, 1, the point 1, 2, the point 2, 3, and the point 3, 2.5. In this case, we're creating a list with numbers ranging from 1 up till 9 for the x-axis and 1 for the y-axis with numbers which are part of an exponential curve. Now we can use the plot function and we give it first the x list and then the y list. Okay, so that's also how matplotlib expects you to give the arguments. First the x-axis arguments and then the y-axis arguments. And then we're using the title function this time to give it a title as well. And we're getting an error because we first have to run the cell above and then it works. Okay, so if I would switch them around, you will think that our y list are the x values and the x list are the y values. And then we get the exact opposite. So the order does matter here. We can also combine different plotting possibilities into one plot. So in this case, we're going to plot a line and we're going to plot some scatter points in the same plot. So what do we need to do for that? We give PLT plot function an X list and a Y list. So those are these values, 10, 20, 25, and 30. And here we can also specify the color of that line, which is light blue in this case. You can see that as well. And we're giving it a specific line width, in this case 3. I don't know by heart how thick that line will be, but generally it's just a matter of playing around with the plot, just plotting it and then thinking it would be nicer if it's a bit bigger, and then you just change it. The second thing that we're doing here is using the scatter function, which will plot some scatter points into that plot. In this case, also a list with x values and a list with y values. So here we are having the points on the x-axis 0.3 and y-axis 11. You can see that it is not present here because the x-axis starts at 0.5. I will come back to that in a second. The color of the scatter points are dark green, and the marker, well, this symbol represents the triangles. You can see in the next line that we have set the x limits, so the limits on the x-axis from 0.5 until 4.5, which means that we will start here and we will end here. And then we set a title, an X label and a Y label, being the title of the plot. The Y label is, this is the Y label, and the X axis is, the X label is this is the X label. and that gives us this plot. So even though that we're trying to plot a scatter point at x and y values 0.3, 11, we're overwriting the limits of this plot with the xlim behavior function here. If we would set it at 0.0, then now we can see that this plot, this scatter point is included. We might use an asterisk, and I'm not sure if dark red is a possibility. Maybe it is. And instead of light blue, let's take dark blue. Also not sure if this exists. And let's take a line width of 7. But just to show you that you have a lot of flexibility, which not necessarily makes sense. At least not if you want this plot to be part of your PhD research, but at least you can do something like this. Oops. Something fell down. So these are line plots, scatter plots. Let's have a look at a bar plot, and let's think that we read in that gene.fasta file and we extracted the amount of times we counted an A nucleotide, C nucleotide, G nucleotide, and T nucleotide, and put that in a percentage. So we have the percentages of A's, C's, G's, and T's in a specific file. We're storing it here in a variable, in a list called height. And then what we also need to do, if we're talking about bar plots, we also need to have a tuple with the names of the bars. And then we can use the bar plot function, which is just bar, and give it the x values, which are the names of the bars, and then together with the y values, which are then here these percentages. And then we're changing the x label, y label, title. You can see that the order doesn't really matter. Whether you first define the title and then the y label and then the x label, whatever, it will work nonetheless. By default, you can see it's a blue color, arguably not very interesting. So what you can do is you can give it assign to the variable color a number of colors, in this case 4 colors, because there are 4 bars that need to be plotted. Not sure if you're familiar with the hexadecimal codes of colors, but you could also say you could also define colors like this: green, red, yellow, and blue. Arguably, that's maybe not the most beautiful. It is the same color code than R. These are actually, conventions is not the proper word, but you use it everywhere in all programming languages. If you go to a shop which sells paints, they also probably use these hexadecimal values. So you can see white is, for example, hashtag FFFFFF. Red is FF0000. And maybe if I do this, I've never used this website. There are websites that can help you with this, though. So So you see every color has a different hexadecimal code. So if I would use this one now, I can change it here. Let's first run this again. Voila. Are those not HTML codes? You have 3 different ways of how you can define them: RGB, hex, and HSL. I presume that they are called hexadecimal codes, but maybe yeah, maybe it's HTML. I don't know. How to check what arguments are included in one function? That's a good question, and this is a good moment to highlight that. So what I generally do is matplotlib plot function. So this is the documentation of matplotlib. At least this is the website that contains a documentation. And if you scroll here, so this is for the plot function explicitly. So not the bar plot or the scatter plot, but the really line plot bar plot function. You can see that it accepts an X and a Y argument. And then there are a bunch of other arguments, such as, where is it? The color, which we have used. The L, the line width, which we have used. The line style. With this you can set like dashed lines or something like that. Point lines, dash and point lines. You can set, I guess these are the most important ones. But you can find in the documentation always a full list of all of the options that you have. And then this is a very, I would say, complex example, which I've included just to show you that there is a lot of flexibility. And this is the figure that we will plot. It contains 2 bar plots with an error flag. Some labels here on the x-axis. A y label and a legend. And because of we need to plot 2 bar plots, we also need to specify a specific location where we want to plot the x-axis label here, or the bar plot label, sorry, is a better explanation. So that creates a bunch of complexities where you need to think about. If you want to make such a plot, should I go over it? I think so. Basically, these 2 lines will plot the 2 bar plots. So the first one will plot the dark blue ones, and the second plot function will do the cyan blue plots. And you give it an R1 variable with X values, and experiment A are the Y values. You're defining the width of that bar plot. You're defining the color. You're defining that the edge color is black, so around the bar. That it has an error flag with those values in the variable y1. The cap size 5 represents the width of this error flag. It also has a label being experiment A, which will then be printed in the legend. The second one works the same way, only that we change the color to cyan. The cap size is a bit bigger and we give it a different label, obviously. And you can see that for the R1 and R2 variables, the they are created here, right above it. For the first one, it's fine. You can just use any list of values that you like. But the second set of x values for the second bar plot are a bit more complicated because they need to start. If your first bar plot starts at the point 0 and your bar is 0.3 in width, then your second bar plot needs to start at 0.3. So that's what's happening in this and this line here. We're defining the x values. There's a couple of other things that you need to think about if you're making these kind of complex plots with Matplotlib. They are there for you to discover. Generally, what I would say is that you do not have to go to the internet and try to find it yourself. How you try to find yourself how you need to do this. What I did to get this, and it's actually surprising me that I do not have it in here anymore. Yes, that's. So you can see that actually I basically copy pasted the code from here, from this website, and then I tweaked it a little bit to my likings. And that's basically how I suggest that you would do it as well. You can go to a website and try to find a specific plot that you want to make, and then use that as a basic layout to start making your own plots. Imagine that you want to create, let's call it a violin plot. Different possibilities here. You can see that you can do that with the Seaborn package, and then you can use this code to start create your own violin plots. So I highly recommend you, I'll type the link here, to just Google whatever plot it is that you want to make, and then dive into the literature of that plotting library that you might find, and go and discover it yourself. If you're looking at more, well, someone asked me once how you can create Venn diagrams. These are, for example, not part of the Matplotlib library. What you then can do, what I did find was that it's part of the matplotlib_venn library, which I could only install with pip install. So that's what I did here. Once I did that, I figured out that you need to have a bunch of other libraries imported before you can use it, such as NumPy, SciPy, Matplotlib, and Matplotlib_venn itself. So those are the import statements that you need to use. And then you can use, for example, 2 lists of genes, and we're now trying to find the genes that are both in list 1 and list 2. And then you can use the venn2 function, which is part of the Matplotlib_venn library, which accepts 2 functions, the subsets and the set labels. The labels contain a list of what you will call the different circles, and the subsets contain then a set. So that's another data type which we didn't cover. So besides lists and tuples, you also have sets. So we're making a conversion of this list of genes to a set. Same for the second list of genes, and that we are feeding to the subsets. And then it will make this not so nice Venn diagram. So yeah, it's at least some information, at least some introduction. I agree that it's not the most useful thing, but at this point there is not much sense for me to go over all of the plots that you can do with Matplotlib or Seaborn or Plotly or Bokeh or whatever library that you have in mind. It's really up to you now to discover that library. I think you have all of the fundamental knowledge in Python to figure out how you, for example, can do one of these plots that are being that you can choose here, for example. So that's at least how far I'm concerned, everything there is to know about the basics of Python. There is nothing much more that I want to talk about now. If there for some chapters there are extra course parts, for example on the lists and tuples. If you go to extra course parts, you can read a bit more on sets, how they work. We left it out of the course materials because otherwise it would just be too much. Python is a very big language. There is a lot to learn, and I think you can just keep learning. But it wouldn't really make sense at this point. It would make more sense that you think about a situation in your lab, in your own research, in which you can apply Python, and then just try to tackle it. Try to translate that problem into subparts which you could be able to program in Python, and then start to try to figure out each step separately. Last week I got an email from someone that followed the same workshop in November, and she didn't do anything with the Python that she learned back then, which resulted in her having to say she didn't remember anything of it because she didn't use it anymore. But now she had a great idea for which she could use Python. And so she sent me an email explaining the problem, and we had a chat yesterday, and we started to work on this problem. And so I think we will get somewhere. We'll see how far it gets, but at least it's important. And with this example, I want to stress the fact that if you are stuck somewhere, if you have a question, don't hesitate to send us an email. You should have our emails, so that should be all right. If you're scared to send us an email, or if it's maybe a very small problem, it might make sense that you also search one of the many blogs that are out there, or fora like Stack Overflow. A lot of answers are given there. Usually I say, if you're asking yourself a specific question at this point, probably someone else has asked it himself earlier before you. So yeah, go ahead and Google it. I do it all the time, so there's nothing wrong with it. And if that doesn't help you, the documentation is also always there. And then it's just a matter of practice, practice, practice. However, I would say just try to implement your knowledge into something useful. It doesn't make sense to keep watching tutorials and keep following workshops. You learn the most if you can just do it yourself in some project. And that's it basically. I'm going to answer John's question in the chat, which is how can you store a figure? There is one line that I skipped. In where is it? Somewhere in the beginning, somewhere in the middle, there is a line that says plt.savefig. That will store a figure for you. If I run this again, it should appear here. It took some time. So you can see now that there is a PNG figure created with the exact same name as we defined here. So if I go to my folders, I can now see that figure in my files. Okay, so that's it for me. I leave it up to you whether you stay here with me and try to solve one of the last exercises which we didn't cover, or maybe more interesting, work on the project exercise. You can try to finish it now. Maybe it doesn't work, I don't know. You can continue it at your own time. At any point, if you have any questions, you can always come back to us. Don't worry. I will be here at least until 5. Probably a bit longer as well, but it's completely up to you what you do now. We've covered all of the materials and you're free to go. You're free to go after after you filled in our feedback form, which I'm now going to copy paste in the chat. So that would be very nice if you could still fill that in. And then I encourage you to work on the project exercise. And otherwise you can always leave, of course. If you're leaving, thanks for being here. It's a bit weird doing this everything online, especially if I don't see any faces, if I don't hear anyone speaking, because it's difficult for me to estimate how good everything is going. I hope it was less or more okay. Also, sorry if I struggle over my words. Sometimes these days are very intense for me as well. At least I hope you learned a lot, and if it was too much to take up, yeah, don't worry. I think with all of this knowledge that you have now, just seeing some examples, you know that it exists, and if you need to start working on your own project, it will help you yeah, to move forward at least much faster. So, and also normally James is here to keep an eye on the chat. Today, because of personal problems, it wasn't really possible. My apologies on his side, or how should I say it in English? Yeah. There are good reasons for it. If someone still has a good Python joke, hit me up. Ui. My camera was disabled.